And when people talk about energy, they usually focus on three things: oil, natural gas, and increasingly the renewables like wind and solar. But there is one energy source that is rarely discussed at the same level. Despite having one of the highest energy density known to mankind, that energy source is uranium. To understand why uranium is different, we need to start with a simple comparison. 1 kilogram of coal produces roughly 8 kilowatt hours of energy. Now, 1 kilogram of oil produces about 12 kilowatt hours of energy. But 1 kilogram of uranium through nuclear fission can produce over 20 million kilowatt hours of energy. That is not an incremental improvement. That is a completely different scale. In fact, uranium contains more than 2 million times of energy of coal by mass. This difference changes how entire energy systems are structured. A typical 1,000 megawatt coal power plant requires millions of tons of coal each year. A nuclear power plant with the same capacity requires only a few dozen tons of nuclear fuels. This means less transportation, less storage, and fundamentally different supply chain. But the energy density is only part of the story. The more important factor is stability. The renewables like wind and solar are growing rapidly, but they are inherently intermittent. They depend on weather condition and the time of day. Natural gas is flexible, but its price and availability can be highly volatile, especially in geopolitically sensitive regions. Nuclear energy, on the other hand, provides a continuous, stable power output over long periods of time. That makes it a base-load energy source, something modern economies cannot function without. We saw this clearly during the European energy crisis in 2022. As natural gas prices surged, countries with a higher share of nuclear power, such as France, were better positioned to maintain electricity stability. In response, several countries began to reconsider nuclear energy. The UK expanded nuclear plans. France reaffirmed its nuclear strategy. Even countries that previously planned to phase out nuclear started to reassess their decision. But uranium is not just about electricity. It is also deeply connected to national security. Nuclear submarines, aircraft carriers, and of course, nuclear weapons. And all of this depend on nuclear fuel and nuclear technology. So uranium sits at the intersection of energy and strategic power. And here is where things about to become even more interesting. Despite its importance, the uranium market is relatively small. The global uranium market is worth only tens of billions of dollars. By comparison, the global oil market is worth several trillion dollars. So we have a paradox. A relatively small market with a disproportionately large strategic impact. This reveals a broader principle. In many systems, the most important components are not the largest one. They are the one that defines the limits of the system. Uranium is one of those components. Now, of course, nuclear energy is not without challenges. It requires a massive upfront investment. The project can take more than a decade to complete. There are safety concerns and long-term waste management issues. These factors have limited its expansion over the past few decades. But the global context is changing. Electric vehicles are increasing electricity demand. AI and data center are consuming more power than ever before. Industrial electrification is accelerating. All of these points to one trend. The world will need significantly more stable electricity. And that leads to a fundamental question: which energy source can provide large scale, reliable, and long term power? If we look at the system as a whole, and each energy type serves a different role. Oil dominates transportation, natural gas acts as a transition fuel. Renewables drive decarbonization, but nuclear energy plays a unique role. It provides high density, stable, low carbon power. That is why uranium, despite being less visible, may be one of the most important foundation of the future energy system. The future of energy is not just about new technologies. It is about which system can deliver power reliably at scale over long periods of time. And in that equation, uranium is not just another resource, it is a strategic foundation. If uranium is so important, then the next question becomes unavoidable. Where is it located, and who can choose its supply? In the next episode, we will break down the global uranium map.